I'll say it loud, I'll say it clear. I'm gonna tell you what's happening here. Glycolysis is the start of respiration, which is the breakdown of glucose and ATP formation. It gives us energy. Cell respiration takes patience, takes dedication. O2 inhalation, motivation. The cycle of glycolysis is really neat. Yeah, we're talking about sugar, really sweet. We begin with glucose, it's the start of respiration. We end off with pyruvate, there's no complications. Leave the rhymes to me, I'll do some narration. Leave the learning to you, now that's education. Don't worry guys, we'll take this real slow. We'll start from the beginning with our 6-carbon sugar, whoa! If we were playing baseball, glucose would be the first base. An enzyme and an ATP help step 1 take place. ATP is the energy, hexokinase is the enzyme. The first step is easy and it really is a fun time. ATP will lose a phosphate and become a DP. This phosphate's now on glucose, this is easy, can't you see? Now we're on to step 2, let me break it down for you. After this phosphorylation, there is no hesitation, there's a slight mutation and a fructose formation. The enzyme phosphoglucomutase finds new ways to bring the molecule that we have to the next phase. It's isomerized. Up, down, and sideways. This molecule is changed. Rearranged. Step 2 explained. Info exchanged. It was glucose 6-phosphate, now it's fructose 6-phosphate. Now we're on to step 3. Listen to me. It's a repeat of step 1 to some degree. Another phosphorylation, molecule preparation, another slight modification, an ATP situation. Phosphofructokinase is the enzyme that helps this phase. A phosphate group leaves another ATP. It's easy. Now it's fructose with 2 phosphates and the rest of the cycle awaits. The cycle of glycolysis is really neat. Yeah, we're talking about sugar, really sweet. We begin with glucose, it's the start of respiration. We end off with pyruvate, there's no complication. The enzyme aldolase should get some praise. It helps the molecule split apart for the next phase. The 6-carbon molecule gets split in 2. Now it's 2 3-carbons. That's some math for you. One is G3P and one I call DHAP, but we don't want DHAP because it's a mishap. Next step's pretty easy. We know we want G3P, but DHAP kind of sucks, so an enzyme constructs. Isomerase turns stuff around. It's what changes DHAP into a new compound. DHAP becomes G3P, and that sounds good to me. Now we have 2 G3P of utmost quality. Each one has a phosphate, there's still one connected, and soon one more will join. G3P will be affected. Since there's 2 molecules, it's important to know that the next steps happen twice, but that's obvious, hello? Now on to step 6, and this one is pretty cool. NAD plus isn't anybody's fool, an electron carrier with a lot of motivation to remove a hydrogen from this whole situation. Once the electron's gone, a phosphate can come on. It was chilling in the cell, now it's doing pretty well. Phosphate is attached, an enzyme helps. It's got a long name, so I'll just spell it out. TRIOSE phosphate DEHYDROgenase. At the end of this step, we have a new molecule. It's called biphosphoglycerate. Isn't that cool? This step made 2 NADH, yeah! In the next step, ADP comes along and it's lacking a phosphate. You know what's going on. You know what has a phosphate? Or biphosphoglycerate. In the substrate level, phosphorylation, we end up with a new creation. The phosphate leaves the 3-carbon molecule and joins with ADP, which will form a great tool. Phosphate plus ADP makes ATP, which can cause spontaneous reactions because it's packed full of energy. And after this step, we've only made 2, but don't you worry, there's a lot they can do. An enzyme helps, and it's called kinase, and now it's time to learn the next phase. Our phosphoglycerate changes into PEP, and that's why this is the easiest step. Water forms and electrons move. Molecules change and enzymes groove. A mutase and an analase, they'll catalyze always. Now we're left with 2 great PEP, so let's move on to the final step. A phosphorylation, just like before. And guess what's made? ATP galore. ADP will steal the very last phosphate, making 2 ATP and 2 pyruvate. The enzyme that helps us here is kinase, and it's what gets us to this place. We made 2 NADH and 2 ATP, 2 pyruvate in the end. That sounds good to me. This whole cycle was really great. Took some time, but was worth the wait. The cycle of glycolysis is really neat. Yeah, we're talking about sugar, really sweet. We begin with glucose, it's the start of respiration. We end off with pyruvate. There's no complication.
I'm Rosie. No, I'm done with this.